In the spring of 1943, as empires strained beneath the weight of competing doctrines and collapsing fronts, a single sheet of intelligence would quietly map the remainder of the war. It arrived not as doctrine, but as arithmetic. And arithmetic, when verified, ends arguments. March 17, 1943, Berlin. The smoke hung beneath the ceiling in layers, each one marking an hour of waiting. The office smelled of tobacco, old leather, and the particular staleness that settles into wood when winter refuses to leave. Outside, the city moved through its rationed daylight with practiced efficiency, but inside this room on Leipziger Strasse, time had compressed into the space between two breaths. The page landed without ceremony. No stamp marked it urgent. No red ink framed its margins. It was typed on thin paper, the kind that crinkled when touched, and it bore a string of numbers that made no immediate sense to the adjutant who carried it in. He placed it on the desk, stepped back, and waited. The officer who read it first said nothing. He read it again, slower this time, his finger tracing each line as if suspecting a clerical error. Then he stood, walked to the window, and stared at the gray facade across the street for a full minute before returning to his chair. It was not a blueprint for a secret weapon. It was not an intercepted order or a decoded transmission revealing enemy movement. It was a production report. And production reports, when accurate, carry more weight than manifestos. The document described a factory in Michigan, not a complex, not a series of plants scattered across a region, but a single building, one structure. Inside this structure, according to intelligence cross-referenced through neutral Stockholm and cautious Lisbon, the Americans were assembling 4-engine heavy bombers at a rate that defied every principle of aviation manufacturing the Luftwaffe understood. 1 B-24 Liberator per hour. Not per day, not per week, per hour. The adjutant watched his superior's face for a reaction and found none. That absence itself was the reaction. In a war where every number mattered, where every ton of steel and every liter of fuel was calculated and rationed and fought over, this number was obscene. It was offensive. It contradicted the fundamental assumptions upon which the entire aerial defense strategy of the Reich had been constructed. If this were true, then the war of attrition was already over. It simply had not been acknowledged yet. The officer placed the page in a folder, closed it, and locked it in a drawer. He did not dismiss it as propaganda, though propaganda would have been easier to file away. He did not laugh, though others would. He simply filed it and continued with the day's work, because the alternative was to accept that the mathematics of survival had already turned against them. And acceptance in March of 1943 was not yet a permissible emotion. Across the Atlantic, in a place most German officers could not locate on a map, the impossible was becoming routine. The building stood at the edge of farmland, where Michigan soil met the geometry of industrial intent. From the air, it appeared as a vast gray scar across the earth, a single unbroken roof stretching farther than any hangar, any workshop, any conceivable enclosure for the assembly of flying machines. It was not beautiful. It was not elegant. It was a fact made of concrete and steel, and it hummed. Inside, the sound was overwhelming. Not the roar of engines, though engines were tested here. Not the scream of metal under stress, though metal was shaped and riveted and bolted into forms that would carry men through flak-torn skies. It was the sound of repetition. Pneumatic tools firing in sequence, conveyor systems grinding forward in measured intervals, the shuffle of thousands of feet moving between stations, each step timed, each motion rehearsed. The light was artificial, fluorescent, cold. It erased shadows and made every surface visible, every imperfection detectable. There was no romance in this light. It was the light of inspection, of measurement, of a process that could not afford mystery. Albert Kahn had designed the structure, and he had designed it without sentiment. The building was not an expression of architecture. It was a problem solved. How do you contain an assembly line for a bomber with a wingspan of 110 feet? You build a room that does not end. How do you prevent interruptions? You eliminate them. The result was a space so large that workers at one end could not see the other, a perspective that dissolved into haze and distance, punctuated only by the rhythm of station lights and the slow, inexorable crawl of the assembly line. Henry Ford and Charles Sorensen had made a promise that sounded like madness to anyone trained in the careful, artisanal construction of aircraft. They would take a machine composed of more than 1.5 million individual parts and reduce it to a series of repeatable tasks. They would train workers in days, not years. They would turn aviation into an industrial product, as predictable and scalable as an automobile. The engineers laughed, the traditionalists scoffed, and the line moved forward. Willow Run was not born perfect. In its early months, it was a site of frustration, of parts that did not fit, of tolerances that clashed, of a learning curve so steep it seemed insurmountable. Workers called it, "Will it run?" in bitter jest, and the joke spread through the taverns of Ypsilanti like a diagnosis. But the line did not stop. It adjusted. It learned. And slowly the impossible became difficult, then routine, then inevitable. By the time that page landed on a desk in Berlin, Willow Run had already crossed a threshold. The question was no longer whether it could be done. The question was whether anyone on the other side would believe it before it was too late. The smoke in that Berlin office would eventually clear. The page would be read by others, analyzed, debated, and in some quarters, dismissed. But the numbers would not change. 1 bomber per hour. The war had already been decided. It simply had not been fought yet. In the spring of 1940, before the factory existed, before the promise had been made, the equation was already being written, not in boardrooms, but in the silent arithmetic of strategic planners who understood that wars between industrialized nations are decided not by courage alone, but by the capacity to replace what is lost faster than the enemy can destroy it. The doctrine that guided German air strategy rested on an assumption of quality over quantity. Each pilot was an investment, trained over months, honed through rigorous selection, entrusted with machines that represented the pinnacle of engineering refinement. The Luftwaffe believed in the superiority of the individual warrior, the ace, the man whose skill could turn the tide of an engagement. This was not merely military theory. It was ideology made manifest in steel and fuel. The American approach was different, though in 1940 it existed only as hypothesis. If you could not guarantee that every pilot would be exceptional, you ensured that every pilot had support. If you could not produce aircraft of unmatched performance, you produced aircraft in unmatched numbers. And if the enemy relied on irreplaceable expertise, you built systems that functioned regardless of individual genius. Detroit had spent decades perfecting the methods of mass production. The assembly line was not invented there, but it was refined there, tested there, scaled there until it became a language of its own. Henry Ford's River Rouge plant had demonstrated that staggering complexity could be tamed through decomposition, that a product could be broken into tasks simple enough for rapid training, precise enough for consistent quality. But an automobile was not an aircraft. An aircraft demanded tolerances measured in thousandths of an inch. It required materials that could withstand extremes of temperature, pressure, and stress. It was, by every conventional measure, a product unsuited to the brutal efficiency of the assembly line. Charles Sorensen did not accept this limitation. He looked at a B-24 Liberator and saw not a flying machine, but a problem of organization. 1.5 million parts, 4,500 pounds of rivets, miles of electrical wiring, hydraulic systems, oxygen systems, armament systems, each one a subsystem that could be assembled separately, tested separately, integrated only at the final stages. It was not a matter of simplifying the aircraft. It was a matter of simplifying the process. In early 1941, negotiations began. The government needed bombers. Ford had capacity, but capacity meant nothing without a structure to contain it. Albert Kahn, the architect who had designed much of Detroit's industrial landscape, was brought in to solve an impossible problem. How do you build a factory for an assembly line that must move aircraft with wingspans exceeding 100 feet? You build a single, uninterrupted space. No columns obstructing the line, no divisions interrupting flow. A building 3,200 feet long, shaped like an L to avoid crossing county lines. and the taxes that came with them. The famous tax turn was not a flourish. It was a pragmatic solution to bureaucratic geography, a 90-degree angle that would later become symbolic of the entire endeavor. Ground was broken in April 1941. By September, the structure was enclosed. By early 1942, machinery was being installed, workers were being hired, and the first aircraft components were arriving from subcontractors scattered across 32 states. The human element was where conventional wisdom expected failure. The Luftwaffe trained its pilots for years. Willow Run would train its workers in weeks. The skeptics pointed out the obvious. You cannot teach precision in a classroom. You cannot replace experience with enthusiasm. But Willow Run was not asking for experience. It was asking for repetition. Each station on the line required a narrow set of skills, practiced until they became reflexive. A riveter did not need to understand aerodynamics. She needed to place rivets in sequence at the correct angle, with the correct pressure. That could be taught. That could be measured. That could be perfected through iteration. The workforce that emerged defied every stereotype the Nazi ideology held sacred. Women comprised nearly a third of the labor force, operating pneumatic tools, welding fuselage sections, inspecting hydraulic lines. Rose Will Monroe, a riveter who became the face of Rosie the Riveter, was not a symbol. She was a data point in a much larger equation. African-American workers made up nearly 9% of the workforce. Immigrants brought skills from textile mills and automotive plants. The elderly worked alongside teenagers. People with physical limitations were assigned to stations where stability mattered more than strength. The line did not discriminate based on ideology. It discriminated based on function. And function, it turned out, was broadly distributed. In the first months, the problems were relentless. Parts did not fit. Tolerances clashed. Assembly stations discovered errors only after hours of work had been committed. The joke about will it run spread beyond the factory gates, carried by workers who were exhausted, frustrated, and beginning to doubt whether the entire project was feasible. But the line kept moving. Engineers revised jigs. Inspectors tightened standards. Workers developed shortcuts that did not compromise quality, but improved speed. The learning curve was steep, but it was a curve, not a wall. Every day, the average time per station dropped. 45 seconds became 40. 40 became 38. 38 became 32. By mid-1942, the mockery had quieted. By early 1943, the line was producing aircraft that passed inspection on the first attempt. And by the time that intelligence report reached Berlin, Willow Run was approaching the tempo Sorensen had promised. Meanwhile, across the Atlantic, the strategic situation was shifting. The 8th Air Force was building its strength in England, preparing for a daylight bombing campaign that would test every assumption about air power. The doctrine was bold. Heavily armed bombers flying in tight formation could defend themselves against fighter attack and strike precision targets deep in occupied Europe. The doctrine was also costly. Early raids demonstrated that German defenses were formidable, that losses could reach double digits in a single mission, that the replacement rate would need to be extraordinary just to sustain operations. The RAF had already shifted to night bombing after daylight losses proved unsustainable. The Americans insisted on continuing, but continuation required a pipeline that could absorb attrition without collapsing. That pipeline was being welded together in Michigan, not by visionaries but by workers on 3 shifts, moving through stations under fluorescent light, tightening bolts and sealing seams and checking tolerances with instruments calibrated to fractions of an inch. The work was not glorious, it was methodical. And methodical work, when multiplied across thousands of hands, becomes strategic power. In Berlin, the intelligence was reviewed, debated, and in many quarters, dismissed. Hermann Göring, head of the Luftwaffe, reportedly laughed at the notion that America could challenge the Reich in the air. It was not merely arrogance. It was a worldview that could not accommodate the possibility that industrialized democracy might function more efficiently than authoritarian control. But the numbers did not require belief. They only required verification. And verification was coming, one aircraft at a time in a rhythm that would soon become undeniable. August 1st, 1943, Ploiești, Romania. The B-24s came in low, skimming over wheat fields and industrial suburbs at altitudes where anti-aircraft gunners could aim by eye. Operation Tidal Wave was designed as a knockout blow against the oil refineries that fed the Wehrmacht's fuel supply. The planning had been meticulous. The execution was chaos. 54 aircraft were lost. Over 500 men did not return. But the mission revealed something else. The losses were absorbed. Replacements arrived. Crews were retrained. Within a month, the squadrons were operational again. The question was not whether the raid had succeeded tactically. The question was whether such losses could be sustained long enough for the strategy to work. Willow Run provided the answer. By August 1943, the factory had crossed into a new operational rhythm. The early struggles had been overcome not through inspiration, but through iteration. Each problem had been documented, analyzed, and solved. Jigs were refined. Training programs were shortened without compromising quality. The rejection rate had dropped to a fraction of a percent. The line moved at a cadence that no longer seemed impossible. It seemed inevitable. Inside the factory, the visual language was one of relentless repetition. Rows of fuselage sections hung from overhead conveyors, moving in synchronized intervals. Wings arrived on specialized carts, precisely aligned for attachment. Engines were lowered into position by crane operators who had learned to judge clearances by millimeters. The workers moved with the efficiency of choreography, not because they were exceptional, but because the process had been designed to make their tasks repeatable. Yet the claim still sounded absurd to those who had not seen it. 1 bomber per hour. Even to American officers who understood the scale of Detroit's industrial capacity, the numbers seemed like propaganda. But the arithmetic was verifiable. By the end of 1943, Willow Run had delivered more than 2,000 B-24s. The average time from the start of final assembly to rollout had dropped to 63 minutes. The intelligence reached Berlin through multiple channels. Neutral attachés in Washington filed reports. Swedish journalists toured the factory and published photographs. Swiss banks processed payments that revealed the scale of subcontracting. Each source corroborated the others. The numbers were not inflated. In the offices of the Reich Air Ministry, the response was fragmented. Some analysts treated the reports as credible and began revising their estimates of American production capacity. Others dismissed them as psychological warfare. Hermann Göring, when presented with the figures, reportedly called them fantasy, the product of a nation that excelled at advertising but not at war. The debate was irrelevant. The bombers were real. On August 17, 1943, 2 weeks after Ploiești, the 8th Air Force launched a double strike against Schweinfurt and Regensburg. The targets were ball-bearing plants and aircraft factories. The losses were severe. 60 bombers were shot down. Another 100 were damaged. The casualty rate was unsustainable by any conventional measure. But the bombers kept coming. Replacement aircraft arrived from Willow Run and other factories. Replacement crews completed training in the United States and were ferried across the Atlantic. The logistics were staggering, but they functioned. Fuel, ammunition, spare parts, all flowed through a supply chain synchronized by clerks and quartermasters who turned paperwork into operational capability. The German response was tactical brilliance constrained by strategic poverty. Luftwaffe pilots were among the best trained in the world. But each pilot lost was irreplaceable. Training a fighter pilot required months and consumed fuel that was increasingly scarce. Each aircraft destroyed took weeks to replace, and the factories that built them were themselves becoming targets. The Americans did not need to win every engagement. They only needed to ensure that their losses could be replaced faster than the enemy's. And by late 1943, that equation was no longer in doubt. At Willow Run, the shifts rotated without pause. The factory operated around the clock, a city within a building, sustained by cafeterias and medical stations and the hum of machinery that never fully stopped. The workers were not soldiers, but their role was understood. Every rivet placed correctly meant a crew that might survive. Every inspection passed meant a mission that might succeed. The light inside Willow Run was constant, artificial, unchanging. Outside, the seasons shifted. But inside, time was measured in station intervals and shift changes, a rhythm disconnected from nature and entirely subordinate to production. In Berlin, the nights were dark. Blackout regulations kept the city invisible from above. But the darkness was also symbolic. Intelligence flowed in, was analyzed, and often disappeared into drawers and files where it could be safely ignored. The truth was available. It simply was not convenient. The strategic bombing campaign would not reach its full intensity until 1944, but the trajectory was already visible. American production was not just outpacing German production. It was operating on a different scale entirely. In 1943, the United States built 85,000 military aircraft. Germany built 25,000. The gap was not merely numerical, it was existential. February 20th, 1944. The skies over Germany. They called it Big Week. 6 days of coordinated strikes targeting the heart of German aircraft production. The 8th Air Force and the RAF Bomber Command committed everything available. The weather cleared. The bombers came in waves. And for the first time, the Luftwaffe could not be everywhere at once. The arithmetic had shifted, not suddenly but through accumulation. Each month, American production had delivered more aircraft than the month before. Each month, training programs graduated more crews. Each month, the logistics network refined itself, reducing delays, improving maintenance turnaround, ensuring that more bombers were operationally ready on any given morning. The German defenders flew with desperate skill. They knew the targets. They knew the routes. They climbed to intercept with engines screaming and guns loaded. But they were outnumbered, and worse, they were irreplaceable. When a Luftwaffe ace was shot down, he took with him hundreds of hours of combat experience, tactical knowledge that could not be taught in classrooms, instincts honed over years. When an American bomber was lost, it was replaced within days. When an American crew was lost, another crew, adequately trained and adequately supported, took their place. This was not heroism against heroism. It was system against courage. And systems, when properly designed, do not tire. Across the Atlantic, Willow Run operated in a rhythm that had become second nature. The workers no longer marveled at the scale. They simply performed their tasks, station by station, shift by shift. A woman tightening hydraulic fittings did not think about strategic bombing. She thought about torque specifications and inspection checklists. A man welding fuselage joints did not consider geopolitics. He considered bead consistency and cooling rates. But the cumulative effect of their labor was geopolitical. Every completed bomber represented not just a machine, but a message. The message was simple. We can do this faster than you can stop it. By the spring of 1944, the P-51 Mustang had entered service in significant numbers. It was a fighter with the range to escort bombers deep into Germany, a capability the Luftwaffe had assumed impossible. The combination of long-range escort and mass production transformed the strategic equation. Bombers no longer flew unprotected into defended airspace. They arrived with cover that could engage and defeat interceptors before they reached the formations. The loss rates, which had been catastrophic in 1943, began to decline. Not because the missions became easier, but because the odds shifted. The Luftwaffe was fighting a war of attrition it could not win. Every sortie cost fuel that was increasingly scarce. Every engagement risked pilots who could not be replaced. Every damaged aircraft sat grounded while mechanics scrambled for parts that were no longer abundant. Meanwhile, the American bomber streams grew larger. Missions that once involved 100 aircraft now involved 300, then 500, then more. The sky itself seemed to darken with formations, the contrails stretching in geometric patterns that marked the routes to refineries, factories, rail yards, anything that fed the Wehrmacht's capacity to continue. In Berlin, the reports accumulated. Albert Speer, the Minister of Armaments, understood the implications better than most. He had spent years rationalizing German production, squeezing efficiency from a system stretched thin by ideology and corruption. But rationalization could only do so much when the raw numbers were so lopsided. German production had peaked. American production was still accelerating. Speer would later write that the air campaign did not destroy German industry overnight. It degraded it, disrupted it, forced dispersal and inefficiency, drove workers into shelters instead of factories. The cumulative effect was a slow strangulation. Output declined not in dramatic collapses, but in percentage points month after month, until the shortages became critical. The collapse was not theatrical, it was bureaucratic. Requisition forms went unfilled, deliveries were delayed. Quality control slipped as experienced workers were conscripted and replaced by forced labor. The trains that moved components between factories became targets themselves, and the rail network fragmented into isolated nodes that could not coordinate. At Willow Run, none of this was visible. The factory existed in its own reality, insulated from the war by distance and focus. The workers knew, abstractly, that their labor mattered, but the connection was mediated by newsreels and radio broadcasts, distant and sanitized. The real war for them was meeting quotas and passing inspections. Yet the connection was absolute. Every bomber that rolled out of the factory became a variable in a vast equation. How many tons of bombs could be delivered per month? How many sorties could be sustained? How long could the enemy's infrastructure endure under sustained attack? The answers were being calculated in real time, not by strategists alone, but by the combined output of factories, training schools, refineries, and ports. By mid-1944, Willow Run had produced more than 4,000 B-24s. The rate had stabilized at slightly less than 1 per hour, when averaged across all shifts, but the consistency was more important than the peak. Consistency meant planners could forecast. Forecast meant strategy could be sustained. Sustained strategy meant the enemy could not recover between blows. The German High Command faced a problem with no solution. They could not bomb Willow Run. They had no bombers with the range, no fighters with the fuel, no intelligence network capable of coordinating such a strike. They could not disrupt the supply chain. It stretched across an ocean they no longer controlled, and a continent beyond their reach. They could not match the production. Their factories were smaller, their workforce was depleting, their raw materials were constrained. They could only watch the numbers grow, and hope, against arithmetic, that something would change. But hope is not a strategy, and arithmetic does not negotiate. The lesson was written not in doctrine, but in ledgers. By the end of 1944, the numbers told a story that no amount of tactical brilliance could rewrite. The United States had produced nearly 100,000 military aircraft that year. Germany had produced less than 40,000. The gap was not closing. It was widening. Willow Run alone had delivered more B-24s than the entire Luftwaffe produced bombers of all types. This was not a comparison of quality. It was a statement of capacity. And capacity, in industrial war, is destiny. The philosophy that guided Willow Run was fundamentally different from the philosophy that guided the Reich. The German system valorized the exceptional individual, the pilot with 50 kills, the engineer who designed the jet fighter, the commander whose tactical genius won impossible battles. These were real achievements, celebrated in propaganda and enshrined in doctrine. But exceptional individuals do not scale. A nation cannot build an air force on aces alone. It cannot sustain a war economy on genius. Genius is rare. Process is replicable. Willow Run was built on the assumption that ordinary people, given clear tasks and adequate training, could produce extraordinary results through repetition. The riveter who placed 10,000 rivets did not need to be exceptional. She needed to be consistent. The inspector who checked tolerances did not need to be brilliant. He needed to be methodical. This was not merely an industrial insight. It was a moral one. The Nazi ideology rested on hierarchy, on the belief that some lives were worth more than others, that some people were born to lead and others to follow. Willow Run operated on a different premise. It treated workers as interchangeable not because they lacked value, but because the system was designed to distribute value across many hands. The diversity of the workforce was not incidental, it was structural. When you design a process that relies on replicable tasks rather than irreplaceable talent, you open the door to anyone who can learn the task. Women, African Americans, immigrants, the elderly, people with disabilities, all became assets because the system measured output, not pedigree. The contrast could not have been starker. The Luftwaffe lost pilots it could not replace. Willow Run trained workers it could multiply. The German factories relied on skilled craftsmen whose expertise took years to develop. Willow Run relied on processes that could be taught in weeks. The Reich hoarded resources and tightened control. America distributed production across thousands of contractors and synchronized them through logistics. In the air, the lesson manifested as overwhelming presence. By 1945, the bomber streams were so large that German defenders often could not even reach them before fuel ran out. Missions that once required careful planning and calculated risk had become routine. The uncertainty was gone. The outcome was statistical. On the ground, the lesson manifested as collapse. German infrastructure, already strained, began to fragment under sustained pressure. Refineries operated at reduced capacity. Rail lines were cut faster than they could be repaired. Factories dispersed into forests and caves, sacrificing efficiency for survival. The war economy did not explode. It suffocated. Albert Speer, in his post-war testimony, would describe the air campaign as a terror that arrived not in dramatic moments, but in cumulative weight. Each raid was survivable. The sum of all raids was not. He would admit reluctantly that by early 1945, German production was collapsing not from lack of will, but from lack of means. The numbers were unbearable. At Willow Run, the war ended without ceremony. The last B-24 rolled off the line in June 1945. The workers clocked out, returned to their homes, and moved on to other jobs. There were no parades inside the factory, no speeches. The machinery was shut down, the lights were dimmed, and the building stood silent for the first time in years. The final tally was precise. Willow Run had produced 6,972 complete B-24 Liberators and 1,993 knockdown kits. The total American production of B-24s exceeded 18,400 aircraft. In the broader count, the United States produced approximately 300,000 military aircraft between 1940 and 1945. Germany produced 94,000. These numbers were not propaganda. They were audited, documented, and verified. They represented not just industrial output, but a philosophical victory. The belief that war could be won through superior bloodlines and warrior culture had collided with the belief that war could be won through superior organization and distributed effort. The distributed effort won. The lesson extended beyond aviation. It applied to ships, tanks, trucks, ammunition, every material category that mattered. The Liberty ships that carried supplies across the Atlantic were built using the same principles as Willow Run: prefabricated sections, standardized designs, rapid training, assembly lines that turned welding into a repeatable task. The Sherman tank was not the best tank in the war. It was the most produced, and production sustained over years mattered more than performance in individual engagements. The German Tiger tank could destroy 5 Shermans in a single battle. But if 6 Shermans arrived the next day, the arithmetic favored the side that could replace losses. This was the core lesson. War between industrial powers is not decided by peak performance. It is decided by sustained capacity. The side that can absorb losses, replace equipment, train new personnel, and maintain logistics under pressure will outlast the side that relies on irreplaceable excellence. Willow Run embodied this principle in its purest form. It was not elegant. It was not inspiring in the traditional sense. It was a building full of ordinary people doing repetitive tasks under fluorescent light. But those tasks, multiplied across shifts and months and years, became the arithmetic that ended a war. They were defeated not by weapons but by method. The truth arrived in the form of production reports, and nobody in power dared to believe it until it was too late. The building still stands, Not as it was, not in its entirety, but enough remains to trace the outline of what once existed. The assembly line is gone. The machinery has been removed. The workers have long since moved on. But the structure endures, a monument not to glory, but to method. Walk through what remains and you can still see the scale, the length that seemed impossible, the width that accommodated wings, the height that allowed fuselages to hang from overhead rails. It was never beautiful. It was never meant to be. It was designed to solve a problem, and it solved that problem with a completeness that changed the course of history. In March 1943, a single page arrived in Berlin carrying a claim that sounded like fantasy. 1 bomber per hour. The officers who read it faced a choice. They could investigate, accept, and adjust their strategy accordingly. Or they could dismiss it as propaganda and continue operating under assumptions that felt safer. They chose dismissal. Not universally, not unanimously, but enough. And that choice, repeated across months and offices and levels of command, became a kind of paralysis. The truth was available. It was simply too uncomfortable to integrate into existing plans. By the time the truth became undeniable, it was too late to respond. The bombers were already in the air. The factories were already operating at capacity. The logistics were already synchronized. The war of materiel had been decided not in 1945, but in 1942, when the first workers entered Willow Run and began learning tasks that seemed impossibly precise. The page that opened this story was not a weapon. It was a forecast. And forecasts, when accurate, are more dangerous than bombs because they remove uncertainty. They turn the future into arithmetic. Willow Run produced 6,972 complete aircraft. Each one carried a crew of 10. Each crew flew missions that required thousands of gallons of fuel, tons of ordnance, and ground support from mechanics, armorers, and logistics personnel. Multiply those numbers across all the factories, all the crews, all the missions, and you arrive at a figure that explains why the war ended the way it did. It was not inevitable. It required decisions. It required investment. It required a willingness to trust that ordinary people, organized effectively, could achieve what exceptional individuals could not. The lesson is not that democracy always wins. The lesson is that distributed systems, when well designed, outperform centralized genius over time. The lesson is that ideology collapses when it encounters arithmetic. The lesson is that the most powerful weapon is not the one that destroys, but the one that can be replaced. Albert Speer, in his post-war writings, described the bombing campaign as a slow realization of futility. Each report brought worse news. Each month, the gap widened. He had rationalized production as much as possible, but rationalization could not overcome the fundamental imbalance. Germany was fighting a war it could not afford. America was fighting a war it had already budgeted for. The workers at Willow Run never met the crews who flew their aircraft. The crews never saw the factory floor. The connection was abstract, mediated by serial numbers and delivery schedules. But the connection was absolute. Every rivet placed in Michigan mattered in the skies over Europe. Every inspection passed in Ypsilanti translated into survival odds over Berlin. This was the arsenal of democracy, not a slogan, but a system, not a miracle, but a method. When the last shift ended and the lights dimmed, there was no ceremony because none was needed. The work had been done. The numbers had been delivered. The war had been won not by the factory alone, but by the principle it represented. That complexity can be tamed, that scale can be achieved, that ordinary effort, multiplied and sustained, becomes extraordinary power. The page that arrived in Berlin in March 1943 was a warning. It was ignored until it became history. And history, written in production reports and loss statistics, is unforgiving. The most unbreakable walls are not made of steel, but of belief. Willow Run believed in process. It believed in repetition. It believed that war could be measured and that measurements, if large enough, could not be overcome by courage alone. The building stands as a reminder, not of triumph, but of truth. The truth that arrived too late for one side and just in time for the other. the truth that numbers when verified, end wars.